So a quick review of electron configuration, orbital notation, and electron dot. So configuration for chlorine, noble gas before chlorine is neon, and then we would have 3s2 and 3p5. Remember, you have to write everything that you go through across that last row. Orbital notation, like we did on hybridization this year. You would have the 3s and the 3p. Remember, we only show the highest level. You don't do d's and f's. You would have 2 electrons here, and remember the pattern is to half fill and then go back and pair, so chlorine has that 1 unpaired electron. And for electron dot, you're going to put the 2 electrons there, those represent the s pairs. And then for the 5 p's, the first 3, just like they did on the orbital notation, are going to go in single, and then they go back and they pair. So either way, you have 3 pairs in a single. So the exceptions occur in the transition metal area. Chromium, you would think would be argon 4s2 3d4, but instead chromium actually exists as 4s1 3d5. Apparently half filling a d orbital is more stable than for that atom than having an s pair, and so that's just the way chromium exists. So if you're going to do any ions, you need to start with that configuration and then remove electrons. So copper, same thing. It's instead of 4s2 3d9, it's 4s1 3d10, and so they both have 1 outer electron. And so everything in their column, molybdenum, silver, gold, and tungsten, are going to do that same configuration. For ions, remember, a positive ion means you take off electrons. Aluminum has 13 protons and 13 electrons to begin with, so if you're going to take off 3 electrons to get back to an octet and remove these 3 electrons, then you would only have 10 electrons, which would give you a +3 overall, the 13 positive protons and the 10 negative electrons. And so your configuration is just any. Most of the atoms in the tall columns will get to a perfect noble gas configuration. There are some exceptions. A negative charge means the atom is going to gain electrons to get to an octet in its outer level. And so you can write this 2 ways. You can write helium 2s2 2p6, or you can just write neon, either way. Transition metals were the ones you have to be careful of because atoms lose their highest level electrons first, and even though the 3d might fill last, 4s is the highest level. And so if we were to ionize these transition metals, you would lose the 4s2, and then you would have argon 3d10. So transition metals, because they have the d electrons, often don't have a perfect octet. They have some d electrons left over.